So can I start?
Yep.
All right. So I'm going to talk about today about pluggable endorsement and validation, also known in Jira as 58729. Basically, the basic ability that this feature gives is the ability to run customized transaction endorsement and validation. Now, a question that comes up: why do we even need custom transaction endorsement or validation, right? So the answer is that there are all kinds of use cases where the transactions have special properties that the native Fabric endorsement or validation code it just can't support. By the way, can everyone besides me please mute themselves? Thank you. So, what kind of use cases do we have that require a custom endorsement or validation? For example, three use cases are if you want your endorsement to have unlinkability in the identities, or for example, if you want your transactions to have a validation that is based on UTXO, unspent transaction output validation. Or also there is another thing that is called state-based ownership. Basically, it means that if someone creates an asset, that only that entity has the ability to transfer it to some other organization. So, what are the if we had pluggable endorsement and validation, what would be the requirements of that? First of all, we would want to have dynamic reconfiguration, that the administrator of a peer could add or remove plugins while the peer is running. This is obvious, right? We don't want to cause downtime because of this. Also, we would want it to be safe. For example, a majority, you would want the majority of the channel members to decide on which plugin would run. So you will have a consistency, because otherwise you may have a non-determinism and as a result a chain fork. Also, you would want to enforce that all peers are on the same version. Also, you would want that if, for example, there is a security vulnerability discovered in a plugin, an administrator of the peer could disable it without the need from consent from the entire channel. Also, you would want the administrator to be able to easily view, add, or remove the plugins. Also, you would want them to be testable. Testability is always good. And the last point is you would want them to be compatible, such that if you have peers running different versions, they could run a validation plugin, for instance, that has the lowest version of the peers, and that way you can have channels that are not homogeneous, that have different versions of peer running in them. So how are we going to achieve this? I actually already told how. I leaked the word plugins. So we're going to use Golang plugins that would be loaded into the process dynamically at runtime. The plugins themselves are going to be installed locally on the peers by the administrators. And also the last point, the peers would always know at any given time which plugin they're supposed to use to validate a transaction or to sign a transaction. Any questions so far? Okay, great. So I'm going next to define a couple of things, and then move on to describe the flow. But the definition is important to understand the flow. So let's go over them. We have two things. We have on the left side of the screen, we have the LSCC config. This is where the the plugins are going to be defined per chain code. So we have here a protobuf definition of a chain code metadata package. And here we have a name of the plugin that is going to be used for endorsement and also for validation. Also, we have here something called an argument, which can be also used to further customize the execution of the plugin in the endorsement or validation. Now, on the right side, we have the channel config. Now, what the channel config is basically going to do is it is going to be a map from this string here to a hash that this hash represents the code package of the plugin. So obviously, we would want the hash to be over the code package and not over the binary of the plugin, because if you have different architectures, the binaries would be different. And also, the administrators are expected to inspect the code of the plugin before they give it to the peer, which in turn compiles the plugin and turns it into an executable. All right, so how does the admin interact with the peer? It will have basically four, mainly three API calls. It will have a list plugins API call, an add plugin API call, and remove plugin API call. And it also, the admin could, in certain rare circumstances, it could override a plugin for endorsement in case it wants to do something special. Now, the plugin here is just a definition of it has a name, a description, a hash, and a code package. Now, the important thing to note here is these are only abstract API interfaces, API methods, but in practice, they are going to be added to a lifecycle system chain code. Now, before that, any questions? Okay, I guess either not or everyone is on mute. So let's go over the deployment and operations flow. First of all, what we have is a peer administrator. It receives the plugin source package from someone. It can be either out of band or it can be via some programmatic dissemination method. For example, a chain code or something. Then what it does, it examines the source code of the plugin to see that it agrees with what is written in there. For example, that there are no things that look like infinite loops, no security vulnerabilities, no stuff that can possibly crash the peer, etc., etc. After that, what it does, it invokes a add plugin on the peer, which causes the peer to, first of all, compile the plugin to its target architecture, and also after it compiles it, it puts it into the file system, both the source package and the binary, and also it puts a mapping between the hash and the executable to run, so that when it sees that it needs to run a specific hash, which the channel consented upon, it would know which binary to launch. Now, how do we set this hash? So the channel administrators, they do this collaborative discussion, and then let's say that they decided that some new plugin is going to be deployed. So first of all, what they need to do is to create the definition of the hash of the source package in the channel config. So they make a config update transaction, and in that they create a new reference from the name of the plugin to the hash. Another thing that we need to do is we need to associate some chain code because as we know, everything is in the end affects how a chain code executes how a chain code is endorsed or validated. So the next thing they do, they make an LSC transaction, and in that they specify in this example the example is of validation. So they specify the name that they put in the channel config in the validation of the chain code, in the chain code metadata. This operation was previously known as instantiate. Now, after that, let's assume that the peer got a block where it has this custom validation, or for example, the peer needs to endorse. So what it does, it has the hash, and it was supposed to have the plugin already installed by an administrator in the file system. So first of all, what it does, it looks at up in LSCC. It says, okay, in LSCC, the name of the plugin that I need to run is UTXO_V. And what is the hash of that plugin? It looks in the latest channel config. From there, it receives the hash. And there, lastly, it does a lookup by the hash in the file system where it can load the binary. Now, any questions so far on the flow, on the basic flow? All right. So let's assume that we want to upgrade the plugin. We have two ways of doing that, because we can upgrade a plugin for a single chain code, or what we can do is upgrade a plugin for many chain codes at the same time. Let's go over this. So the first case is we upgrade the plugin for a single chain code. Obviously, we need what we're doing at the bottom line is we change the mapping of the name of the plugin in the LSCC to some other name. So here we see UTXO_V has changed to UTXO_V2. And UTXO_V and UTXO_V2, both they need to have an entry in the channel config. The second thing that we can do is let's assume that what happens if there is a security vulnerability found in the current plugin of UTXO_V. So what we can do is upgrade a plugin for multiple chain codes at the same time, and this can be done only with a channel config. So we'll make a new channel config transaction, which it simply changes the pointer of the hash from the previous hash to the new hash. And in this way, all of the peers in the channel that have UTXO_V as their validation logic, they start running the new version of the code with the new hash.
So one quick question, Yacov, please. Yes. Just wanted to make sure, when there's already a chain code running and in a channel, and we found a bug in the plugin, and so we want to update just the plugin without changing anything else, and so we would do a configuration change, and it'll update just the hash of. We'll put the new plugin and just update the hash of the hash in the metadata. Correct? Nothing else changes.
Correct. Exactly. We just do a config update, and the config update, it's in its own block, so everything works nicely. And the next block after that config block, they all know to look up the new hash.
Okay. The one question I had was, I was not sure when the chain code was instantiated, if you're going to put the fingerprint of the metadata in the instantiation chain code, then this would cause it to change, right? I'm not sure how that works.
So this has actually nothing to do with the fingerprint on the chain code package itself. It is if we equivalent it, this is the fingerprint on the plugin package.
Okay. I'll take it offline, but I was just I thought at some point we discussed, and Jason may know better, we discussed having a fingerprint of the metadata itself as bytes. And since this hash code is part of the metadata, I thought it might end up on the instantiation, but I don't want to take up time now, Yacov. Sorry. Go ahead, please.
So I can tell you the reason that we do it this way. The reason is that if we have several chain codes that all of them use the same plugin, the same validation plugin, for instance, and you want to easily, and you found a problem, a bug in that plugin, you don't want to make an LSTC transaction per chain code. You can just do one config update, and that simply moves all of the chain codes at the same time to work with the new plugin.
I agree. No, I'm not disputing that. I just want to understand if it'll end up on the LSTC's fingerprint, and if it doesn't, good. That's all.
All right. So we can also
and Yacov, just one. Hi, Yacov, just one high-level thing here. So when we allow updating the plugins from the channel configuration, so right now, for example, in any transaction, the read dependency of the chain code version is added, so that when a chain code upgrade version is upgraded between simulation and commit, so that transaction is marked as invalid because it was simulated on some different version and now things have changed. So here now updating from the back channel, basically through the channel configuration, this may happen that some transaction is simulated on some other endorser plugin and is being validated by some other endorser plugin, next version of it. I mean, either could be advanced, I don't know. So for example, endorser could be advanced and the validator could be behind, or other way around.
So first of all, your question applies only to the first type of the upgrade, not to the second, right?
Right.
And I think that this upgrade is in a way very similar to the upgrade that we have now, and you know that we have these two types of ways that we deal with that. The first way that if we have an upgrade inside the block, then we simply mark all of the transactions after that upgrade as invalid, and if we have an upgrade that is if we have a transaction that has an improper LSTC definition that in the blocks after that block that had an upgrade, then as you know it is marked invalid because of the LSTC read. So I think we can do something very similar here.
Yeah, right. That's what I'm saying. Probably some read dependency of channel config of this item or something that you need to add.
Right, but how can you introduce read dependency on the channel config? Is it possible?
There is already a read dependency now.
Yeah, in the endorser code we can do after the chain code execution has happened. So you can perform a ledger read for channel config key.
Okay, that would be perfect, because that would really clear. Because my question was going to be, how can you ensure after an upgrade that changes the version of ESCC, how can you be sure that no transaction after that upgrade is committed will have used the old ESCC? But of course, if there is an explicit read dependency, that would solve it. Thank you.
Well, but Alessandro, I would like to stress out that specifically for the endorsement, you could override your endorsement locally, and that's okay, if you want. For example, if you want, so I have this API called here, set endorsement plugin, that it is useful if you want your peer to use some sort of plugin, but also at the same time do some special operation, for example, which calls some legacy system, in your company. Okay, so I'll move on. We can also remove a plugin if we want. Basically, a use case for that is if an administrator found a security problem or a bug in the validation plugin or the endorsement plugin, it can call an API call on the peer that removes the plugin. And what happens if a transaction comes and this plugin does not exist, then what happens is that the chain processing would simply halt, which is safe. because until then, the channel can recover by simply doing some transaction, or actually, basically, well, it is recoverable. So, how are plugins going to interact with the peer? So, both types of plugins, endorsement and validation, they will have they need the dependencies passed from the peer because they need abilities that the peer has, abilities that correspond to services. So both plugins, if we look at them as interfaces, so they would have one method which is common, which would contain a list of dependencies as interfaces, and the plugin implementer would need to take this list and to cast each dependency to try and see the types of dependencies that it needs, and then once it has all of the list, assuming it has all the dependencies that it needs, then it can initialize itself. And of course, the second method is the plugin-specific method, which is either endorse or validate. So let's go over the API for now, but I will just say that this might change as we learn more. And but from a high-level view, this is basically what it's going to be. So the endorsement plugin would implement the endorse method. It takes the proposal response payload as bytes and outputs an endorsement, which is basically two things: a signature and the identity. And also, it can output the payload of the proposal response payload as well. Why? Because we want to give the endorsement plugin an ability to mutate the redirect sense if it needs to. And the dependencies passed to it would be some interface, which given a signed proposal, it would give back a signing identity, which is an interface that can serialize the public identity of the peer and also sign messages. Also, it would be very useful for the endorser to have access to the state. And not only to the state, also to the private state, to the public state, and also to the transient store of the peer for all kinds of use cases where it has, for example, keys in it, but the keys are not yet committed in the block, and it stores these keys temporarily. This is more fully elaborated in the design doc. Now, the validation plugin, it will implement the validate method. It needs to know the namespace of what chain code it validates. So we would look at the redirect set and extract from that the namespace. And then also it would have the position of the transaction in the block. And the dependencies passed to it would be capabilities, because we need, as Fabric evolves, it adds more capabilities, and we need capabilities in peers to be in sync for determinism. And also, the validation obviously needs access to the state, so we give it access to the public state, but not to the private state, because not all peers have the private state. And also, we need a way of given an identity, which is serialized in bytes, to be casted into an identity object of the MSP, so we can do a validation of signatures that were created by the endorsement.
So Yacov, Yacov?
Yes.
In the validation plugin, what kind of uses you think of state people might end up using? I mean, I'm just wondering, is it required or can we do without it?
Can you come again?
The state dependency in the validator. So what kind of things you are anticipating? Why would the validator?
You're asking why we would need it?
Yeah, right.
Okay, so for example, if you think of a UTXO model, we would want the validation to be able to compute the unspent transaction set. Or for example,
so can't that be, for example, can't that be done at the simulation time itself? And if it is spent in between, it will fail anyway.
Can you ask again, please? I did not. Someone opened the door here.
Sorry, I think I didn't understand your last sentence, Yacov.
So I said that given the state, we can compute the unspent transaction. The unspent transactions if we have a validation chain code of a UTXO model, and also, for example, it is useful for ownable state.
Yeah, so for UTXO, for example, is it not possible to check the unspent thing during simulation itself, and if it gets spent in between, the transaction would be invalidated anyway?
You are completely right.
My only worry is that if we expect users to write the transactional code in multiple places, like one part in chain code and other part in the state validator, and I think this might basically expose things of complexity where it might be easier to get things wrong as opposed to writing it in one place and let the peer handle it, the validation and invalidation and that kind of logic.
Yes, so you're right.
The only thing I'm saying is the only thing I was saying is, like, if we have a very compelling reason that one cannot do during simulation and marking the invalidation because of the version conflict out of the box, those probably will be more compelling reasons to highlight that we need that complexity because we need these things.
Yeah. So you're completely right, Manish, that you can do it this way, but the advantage of having it done in validation time is that you can make a chain code validation logic which only requires one signature. And in your example, when you endorse, you would need, I would say, much more signatures if the channel has lots of participants. Do you agree?
No, but for that, I think we are solving the problem. But that problem, I think we are solving differently, right? There, basically, we are solving that through local state kind of thing where you can say that who can manipulate the state or not. On the other hand, I would basically think in this case, part of the logic you are executing during commit time, right? So, for example, would you allow changing the state also in the validator?
Again?
Would you allow changing the read write set also in the validator?
No. As you see, we only have read abilities from the state, not write abilities.
Okay, yeah, I think and just a suggestion that we should think little more on adding this front if it is not possible by any other mean handling peer out of the box. Exposing it to application might lead to little complexity for the application writers. I don't know.
So you are right that this does incentivize, in a way, advanced users for certain abuse, but you don't have to do that, right? I mean, first of all, implementing this as dependency is very trivial since we already have that. And as you know, basically, I took the same method from the ledger itself, right? And
no, I'm not saying basically implementing from our side. I mean, of course, that is not much difficult. I'm just thinking from the user point of view, the way he's writing the transactional code. Typically in traditional systems or by nature of it, it's given such a simple way that here is the begin, here is the commit or rollback, do whatever you want to do within it. And rest underlying infrastructure will take care, or should be, unless basically you have very different compelling needs, because otherwise it might be hard. In cases, basically, it might not be that easy to get in right in the application space if the logic itself is spread across components. That during what time, what will happen. So, for example, user will have to understand our transaction processing model, that right now simulation is going on, something you have generated. At the other hand, you are giving me after checking read date set or before checking read date set, I don't know. But I have to check the state, and you have to give me the state, which basically is up to the last transaction in the block. So all these complexity user will have to understand in complex cases if he is writing some code of that nature, which I think, might not be a good idea to expose to the user.
So, Manish, I would like you to express your concerns in the public Google Doc.
Yes, sure, I will add this comment.
Okay, thanks. So this is it for the, as I said, this is a preliminary design review session. So there is no implementation yet, but I would like to hear other comments, concerns, perhaps anyone from the community.
So this is Murali again. Just to go back to the other point that you and Manish are talking about, I think one thing that is actually, this is good in a way, I think, Manish, and I could be wrong. Don't we have other use cases where, things will actually fail because of we are being strict on double spending kind of things, but we do want to look at the state and sometimes allow the validation to make things pass, even which would have failed otherwise, right? Don't we need to know the state and the state information for that kind of use cases that we keep coming up with?
Yes, right. In that case, I think I would probably argue for having a execution transaction, that you execute transaction fully at the commit time, and at that time you have full state with you. So think from the application writer point of view, he is writing exact same code, whether during simulation time, whether during, he's just marking that this is the execution transaction and I want to execute it at that point in time. So in that case, the code he's writing is exactly same place between the start of the method and end of the method, and it's done. You need to take care basically what piece will be executed in what circumstances, and how should I get it right.
So Manish, even if assuming we don't use that for UTXO, you do. I guess you did read the ownable state document, and there we still need that in order to validate transactions that are signed by public keys of users, that the public keys are in the state, right? And
yes,
I think that
and for the UTXO model, we need such like a capability, like what Murali mentioned, I believe, that you need to check at validation time whether a certain serial number or the certain output has been spent. And if the transaction goes on, like the validation succeeds, then you need to add something to the ledger indicating that the output this transaction refers to has been spent. And this is something
so what I'm saying is all this you can do during simulation time, right? So for example, you will read the unspent transaction, you will mark them spent during simulation, you will produce the output,
yes.
And finally, when
you shouldn't have to do any of that during simulation time, though. You should not have to do that during simulation time.
Right, it's
no,
not
what
going
I'm
to be
saying is that
efficient at all.
what I'm saying is in our current model, if you do all this during simulation, you don't need to do anything, custom thing, right? Or do you think you will miss something?
So depending on how you implement the UTXO, it might be that all these marking a certain output as spent is modifying the same part of the state of the ledger. There are cryptographic schemes, for example, that in order to have privacy, you need to update a single value over and over again. And if you do it at simulation time, you will automatically get conflicts at validation time, which would end up many of your transactions get rejected. In an ideal world, we would like this state update to be performed at validation time. Paying special attention, of course, because we know we have parallel transaction validation in place, and we want to make sure that double spending is not possible just because of this. So there are things that need to be put in place, of course, but that being tackled, we also need to have some set state ability at validation time. Ideally.
Yeah, right, Elisa. I'm just extending that particular argument. So, for example, if we feel the need, the primary need, I think, is because we can get many conflicts and hence transaction rejection rate could be quite high. And in those kind of circumstances, this simulation model is not sufficient because one of the basic assumptions in this is that conflicts are low. And anyway, I mean, that is given that if we follow this simulation and commit separate, then that is the basic assumption. If it is violated, then of course rejection rate will be very high. The only thing I was trying to argue for was that in order to solve that problem, shall we rather have a transaction type altogether differently, which fully executed during commit time? Because mostly, as you described here, checking the spent thing, marking them spent, and producing output actually is being done in the validation. So state is being modified, validation is being done. So mostly like what is left, and why to have this complexity? Why not simply introduce a new type of transaction that this whole thing will be executed during commit time and there will be no conflicts and rejection dates?
Well, but Manish, you don't have actually to write that computation inside the state. You can just compute it in memory and just update it each time you have a new transaction, right?
Sorry, Yacov, I probably didn't understand that last thing you said.
So you said that regarding that data structure that Eli said that we would want to update that relates UTXO. So you don't really have to commit that data structure. You can just save it in memory, for example.
You mean you won't commit the changes to the state?
Not the changes to the state. So I suggest this call is not the ideal platform to discuss these
let's take it offline.
Right. Yeah. But you do agree that regardless of the unspent transaction model, having the state as a capability given to the validation plugin is essential for other use cases, such as ownable state, to retrieve the public keys that verify whenever some state was transferred from one organization to another organization.
Right. And in the current design, right now, you're only allowing read-only access to it, correct? Yacov, I mean, the interfaces are just get states, right, not mutate states.
Yeah, exactly.
Yacov, I have a question. So let me say that I really like the interfaces you've put together. They're really clean and they simplify testing and all that. So in that spirit, I was wondering whether you thought it made sense to take the current default ESCC and VSCC and rewrite them as plugins. The default ones in this case, as plugins following the interfaces you have defined.
So this is not in the scope of the current work. Actually, what is going to happen to them, they're simply going to be run via the same wrapper that would drive everything, but you will still have like the built-in vanilla ESCC and VSCC at least for now. This is not part of the work. I mean, we're not deprecating the SCCs.
But I do think Ali brings up a good point on whether or not we should say I don't think we have to externalize them, but we should make sure that they adhere to the interface, right?
Yeah,
so is that what you meant by the wrapper, right?
Yeah, exactly. So they are going to be wrapped with the same mechanism, but underneath, at least for now, they are going to stay the same.
Okay, but it's a consensus that we want to get to a point where our default ESCC and VSCC will look like E and V plugins using your, nomenclature sometimes down the road.
For what it is worth, I think that
I think what you can do, right, is have them. See, the nice thing about the way if we implement plugins correctly, right, is we can have some things can actually be compiled into the peer, right? So the plugin mechanism is really for, like, for example, we may decide like that something should be a permanent part of the peer, right? And then we should just actually have it built in, right? I don't think we have to distribute everything as plugins. But they should be implemented. Code should be implemented the same way, is the way I would put it. We kind of do this today, right? In a couple of places, right? Like already, right? Like we have some there's a built-in like auth handler, built-in stuff, right? So as long as they implement the same interface, it actually doesn't matter technically whether it's a plugin or built-in.
Right. I mean, one thing I would add to that, Gary, I think from a purely performance point of view and all that, it would really make sense to do what Ale was suggesting, right? If you're going to do this, you might as well do it for the defaults also, and so that way, we get it first is uniform, but at the same time, we'll have some performance benefits as well. Only thing is, like Yacov was saying, what happens to all the backward compatibility thing, which we have to solve anyway?
Well, it should still be compatible, right? These are all transparent to everybody, right?
I was thinking people have already deployed as ESCC, 1.1, with using the other ESCC. But if we have to replace that with this, I guess it's under the covers. They don't care. You're right. Absolutely.
Yeah.
Oh, but
hopefully they shouldn't care.
Yeah.
But if they deploy the ESCCs or VSCCs in 1.1, they can just redeploy them with plugins. It does require a work of administrators to install, but it's not that of a problem.
Right. No, I was just thinking we'll make it easy for the users to not have to do that by doing it ourselves and putting it inside the fabric.
I don't think this use case is actually important enough in order to have a dual loading of validation code, because that would surely be much more complex and create a mess. I think that this step with moving to interfaces is the right step, both short and long term. And I think that if someone has a 1.1 custom VSCC running a chain code, it's really not that of a problem to just when it upgrades to 1.2, part of what it needs to do, it can simply write a plugin which invokes its chain code. It's not that of a problem.
I think we are saying the same thing, Yacov. I agree. What I thought Ale was suggesting was replace the default ESCs and VSCs that we have today with with your plugin, which would make sense from a performance point of view and so on, and make it uniform. And that's what I was plus oneing.
Well, I think we can discuss that at least after 1.2, because we do need to be backward compatible at least for upgrades, right? From 1.1 to 1.2.
Okay.
Yep.
Any further questions? I guess not. So that's it then.
Thank you.
All right, so, all right, that sounds like this wraps this up. On mute. This wraps this up. Just a reminder, I'll post this recording on the playback wiki. There's also a review tomorrow at the same time, same information, same call-in. I'll repost everything on the appropriate channels. I'll add the password this time. Looks like everybody took a good guess and got the fabric as a password. If there's nothing else, then I will close the call. Going once, going twice. All right, we'll close the call. Thanks, everyone.